Hello everyone. Today we're going to have two videos for this lesson. The first video is going to walk through the challenge question, which was posted from last week, and talking about the change of base formula with how to use it on the desmos scientific calculator. And then the second video is going to walk you through the process of solving exponential and logarithmic equations when things are not common. So first off, we're going to start off here with the challenge question. In the challenge question unit, it was asking you to solve the equation. So we're trying to see if you could take what you just had from the last lesson to see if you can apply on how to solve. So currently, we notice that the bases here are the same. So because the bases here are the same, and we are adding using the addition rule, when you are adding between logs, that means we actually are going to end up multiplying the expressions. So we're going to take this solution here times this solution. So x times x minus 9, and then it becomes a single log. Our goal is always to get from expanded logs down to a condensed form of logs. And at this point, we're hoping that we have logs on both sides so we can just drop it. So like if I had log 6 of x is equal to log, let's say 6 of 36, then we can just say x has to equal 36 because the bases are the same. But here, since we only have one log and to a value, we have to switch from logarithmic to exponential. So we have to go 6 to the second power is equal to our solution. So here you are changing from logarithmic form. We're going to convert that into exponential form. So when we can't solve in logarithmic, we switch it to exponential, which leaves us to be 6 squared equals x squared minus 9x by distributing the x. So it's base to solution, or base to the exponent is equal to the solution. So I like to go loop and swoop to kind of make that natural rotation of finding the value of x. So now we just use our algebra tools. So 6 squared is 36. And then after that, we move the 36 to get set equal to 0. As soon as we have a set equal to 0, now we're looking for factors of 36. So I'm going to do my x. I'm going to go negative 36, looking for factors that equal negative 9, which gives me negative 12 and 3. So these are my factors, negative 12 and 3. So my factors of x minus 12, x plus 3, which after solving those and setting those equal to 0, you get x equals 12 and x equals negative 3. So that right now, here is our solutions and our answers to this question. We just have to make sure that when we plug these back in, negative 3 doesn't come out to be a negative here. So I plug 12 in, we're good here. We plug 12 in, 12 minus 9 is 3, so we're good. X equals 12 is a solution. But when we plug negative 3 in here, you get log 6 of negative 12. Can we take log of a negative number? So we have to make sure that this expression here is going to be greater than or equal to 0. Actually, not equal to, just greater than, I should say, sorry. It should just be greater than 0. And thus, since it comes out to be a negative, this is not one of our solutions, and our only solution then that would make this statement true, log base 6 of x plus log base 6 of x minus 9 equal to 2, would be if x is equal to 12. So the idea is when we're taking the addition rules, we're applying the 7.5 concepts of property of logs to condense it down to a single log. And then we're going to learn the process of what do we need to do in this situation. All right, so some of this is like the end result of this lesson, what we want you guys to be able to show and demonstrate on a continuous basis. So looking at our objectives for today, we're going to talk about common logarithmics. We're going to evaluate logarithmic expressions using change of base formula. That is video 1. And then video 2 will be solving exponential equations and inequalities using common logarithms. All right, so to start off with, we've linked in the desmos scientific calculator. The reason that we're trying to get you guys to go here is because the process on phones and mobile devices are not always the same. And every calculator seems to be different. So I'm going to kind of use the desmos scientific one that will template what we use in class what most calculators that you guys see will have, and it's also a web-based calculator for you guys to use. So you guys can click on this link, we'll be able to access it. So for me, I'm going to kind of exit out here. We're going to kind of be bouncing back and forth. So the first question I'm asking you is to guys just to evaluate log of 5. So to use this, I went to desmos.com scientific. Mostly your functions and your buttons are going to be here. So you got the squared, you have the exponent of 2, 3, or 4, and then you have the square root and the nth root. But in order to get to our log function, we have to be using the function button here. So we're going to go function, and then this is where all of our operators and expressions we can use. So for today, we're going to use log. So if I'm looking for log of 5, we're going to hit the log button and then just type in 5. And then we're going to say our answer over here then would be 0.6987. And if we go to the next one, we'll hit enter here, hit log, type 0.3 in, and you get x equals a negative 0.5229. And then we just kind of continue the process. We're just doing this right now just to kind of get familiar with the desmos part and what it means. So x equals log 7 of 0.84509. And then the last one of log of 0.5 is equal to negative 0.3010. So what this is doing, and you're probably wondering, what are these answers for? What do these answers mean? So let's look at that. So when you use the log command on the calculator, which is why right now the calculators have to be in what's called base 10. So when we have log here, and we have log of 0.03 or log of 7 or log of 0.05, this is actually saying log base 10, log base 10, log base 10, log base 10. So if you look at this, if I go log, think of this as log 10 of 5, and we go equals x, kind of from previous lessons, this is saying 10 to what power is going to equal 5. So 10 to the x power equals 5. And clearly right now we don't have any common bases that we can change 10 and 5 to. So therefore we're trying to figure out 10 to what power equals 5. Well, 10 to the first is going to be 10, so we know it has to be less than 1, and 10 to the 0 is equal to 1, so we know that it's going to be somewhere between 0 and 1 to get 10 to that power. And since it's a whole number, we're converting a base 10, or we're converting a natural number to another natural number, we know that the log base is going to have to be positive, thus 0.69. So on my calculator here, if I were to go, let's go back to the main screen, and I go 10 raised to the power of 0.69897, I'm going to get something extremely close to 5. Thus, log base 10 of 5 is equal to this exponent. So what you're really finding right here is you're finding out what exponent the base is. This base to what value gives me 0.03. 10 to 0.84509 equals 7. Log base 10 to negative 0.3010 equals 0.5. So the reasons we're getting negatives here is because if we look at the expression, you're going to be writing this as 0.3 to the x power is equal to, oops, sorry, rephrase that, erase that. It's going to be 10 to what power equals 0.3. Or in other words, 10 to the x is equal to 3/10. And since this is a fraction that's less than 1, our value here has to be negative. We're trying to change a whole number to a fraction. So therefore, it's going to have a negative exponent. So the question you should be thinking about is what happens if we don't have common base 10? So log 5, log 0.03, log 7, log 0.5, we can all do using the desmos calculator. But if we don't have base 10 and we have, let's say, base 3, log base 3 of 11, I can't go over here and type in log base 3 of 11 because it doesn't allow me to have single bases. So what they created is the change of base formula. What it's going to do, though, is it's going to trait all of them to have a base 10. So the little rule of thumb is right here. So if you have log base a of n, it's equivalent to log base b of n. So b is the original number. And that original number in this case is going to be 10. So we're going to change this log base a of n to be log base b of n and over log base b of a. So they're going to have common bases, and that b value is going to equal 10. So for example, in this one, I see that this is going to be my base. This is going to be my solution value. So in this analogy here, my a is going to be the 3. The 11 is going to be my n. So I'm going to write this as log of 11 over log of 3. And then the thing that's just implied is that this now becomes base 10, this now becomes base 10, and now it turned into a calculator question. So we're now able just to go over to our calculator, and we can just type in log of 11. Make sure we close that parenthesis. So we take log of 11, we want it to find that value. We want it to find that value here. And then we're going to go divide. So back to functions, we're going to go divide, back to the value, and then we're going to hit log of 3. And again, close the parenthesis, and we get the answer of 2.183. So notice the trick that I always tell people is it's always log of the top number over log of the bottom number. So log of top divided by log of the base. So this is called the change of base. This is always when you don't have a common base of 10. So you have 2, 3, 4, 5, 6, 12, a half, 6, 14, all those. So for example here, when we have log base 8 of 6, this is really going to be written as log base 6 over log base 8. Same thing here. We're going to take log of the top number 20. We're going to divide it by log of the bottom number 3. So log 3. We're going to figure out what it equals here in a minute. And this last one here, we get log of 256 divided by log of 4. So again, top number, basement. So bottom number on here, top number on top. And what's interesting about this is when we go over here and type this in, you got log base 11. So we now go log base 6 divided by log base 8. And we get an answer of 0.8615, which is right there. And that's the value that's going to be equal to x. So if I do the next one, if I go log base 20, so I'm going to delete the 6 and go 20, divided by 3, I get 2.72, which is right here. Now, the bottom one here is actually pretty interesting, only because of the fact that it's going to come out to a really nice number. So when we take log base 256 over log base 4, we get the value of 4. And the reason for that is because if we were to change this form, if we were to go 4 to the x power equals 256, 4 and 256 have common bases of 2 or common bases of 4. Thus, this 256 would turn into be 4 to the 4th power. Therefore, the exponents are the same. Going back to what we learned back in 7.3 and 7.2 lessons. So it's kind of all coming together, and we're going to start processing all this stuff collectively. So that concludes video 1. Video 1 is basically just showing you how to do the change of base formula, which is one of our key processes, and also just get familiar with the calculator. So again, it's the functions and it's the log we're going to use, and the biggest thing, make sure you close the parentheses always. If I don't close the parentheses here, it can possibly change our answers. So, and that wraps up for the first video. Thank you. If you have any questions.